So, welcome everybody to AI Signals 27, our final event for 2025. Thank you everybody for braving the cold weather and coming out for an evening of great talks. Nice. So much energy for November, it's great. Can I make these slides work on somebody else's laptop? Let's do it. Which side is it? There we go. Nice. Thank you as always to the lovely Demon, our sponsors. They are an awesome cloud software engineering and AI consultancy based over in Paddington, doing a bunch of cool stuff, including sponsoring us and paying for the pizza this evening, so thank you, Demon. They are hiring, and I am sitting in front of the QR code. If you are looking for roles in data consulting, software engineering, or cloud engineering, do check them out. I actually used to work there, they're nice people. So yeah. I'll leave that there for another few seconds. All these details are on our website as well, should you need them. These are your hosts this evening. My name is Hugh. I'm an organizer of Meetup. We also have Will, who is first-time organizer. I'm going to point to Will. I forgot I made Will do the AV. And Yaswant, who ran one of our events very recently and is another of our awesome organizers. There he is at the back. If you need anybody, there's a question about the venue or Wi-Fi or whatever, do give us a shout and we can help you out. One other thing we can help you with is code of conduct. So we have a code of conduct for all of our events. The short version is be kind to others, do not insult or put down others. All communication should be appropriate for a professional audience. It doesn't necessarily mean you have to be full stiff upper lip, just that if it doesn't fly at work, it doesn't fly here. We do not tolerate harassment of community members in any form. And yeah, thank you for making this a welcoming environment. This is a variation on the NUM-focused code of conduct, so if you'd like the full version, you can check this out on their website. If you have any issues with code of conduct, please find an organizer. Would you like to speak at one of these events? We have some really exciting speakers this evening. By no means do you have to be doing AI for the government or doing very exciting pipeline things to come speak, but if you'd like to, check out our website over at aisignals.org.uk or scan this QR code. We're always looking for people to come show off personal projects they're building, to talk about academic research, to talk about what they're doing at work. So if that sounds like you, please do give us a shout. We currently have an absolutely stonking waitlist also. I think it's about 15 or 20 people. So you may be waiting a little while into the new year, but please don't let that put you off. I'm beginning to think that maybe we should start working with other meetups to share some speakers because we have a lot of interested people. Would you like to be an organizer? As you can see, it's a pretty low bar. I'm doing a pretty rough job this evening, but we'll give it a go. If you'd like to get involved in organizing one of these events, again, you can find all the details on our website. We're looking for people to do things like run AV, edit videos, host events, find speakers, work with venues and sponsors. We're willing to work with people to sort of meet them wherever they are and get you set up to do whatever it is that you want to do. So if that's something that you find interesting, you want to work with communities, you want to meet cool people, give us a shout. It's an awesome team. I'm really grateful for everyone who gets involved. And without further ado, I will just run through our agenda for this evening. So up first, we have Adam Hill from Comply Advantage and the founder of PyData Southampton, who's going to be talking about not another LLM talk, practical lessons for building a real-world adverse media pipeline. Then we have John Sandall, CEO at Coefficient, and at least two other companies, how to measure and mitigate unfair bias in machine learning models. Finally, we have one of our awesome organizers, Kaustubh, from Pinevox, who's going to be talking about seeing the unseen, AI systems that act before disaster strikes. Great stuff. So I will welcome our first speaker of the evening, Adam Hill.
Okay, thank you very much for having me, for inviting me along. So as you can see, the title of my talk, not another LLM talk. As mentioned, I'm the co-founder of PyData Southampton, and therefore I'm often on the hunt for speakers myself. And in fact, if you've got an overabundance of speakers, you can send them down to the South Coast because I have only got a few scheduled for next year, and I'm already panicking what my program is going to look like. But I'm sure if you come along to any of the tech meetups, okay, how many of you have been to an LLM talk before? How many? Keep your hand up if you've been to more than 5 LLM talks in the last 2 years. So I don't know why you're here to hear yet another LLM talk. So the point of this talk very much was to move away, as I'm sure many of you have noticed. People are talking less about, oh, I've done this really cool proof of concept, which is what we were all hearing 2-3 years ago. What I was focusing on here is, okay, what happens when you actually try and take this and move it at scale into a production environment? So first up, I need to acknowledge that what you're going to hear about are the lessons learned, with an illustrative example, from a team of dedicated people that was not just me working in isolation. We had machine learning engineers, data scientists, software engineers, product managers across, in our case at Comply Advantage, what we call the fin crime and the ingestion tooling teams. So this is, an homage to all of them. I'm just here talking on their behalf. But first of all, who am I? Why am I talking? So it's a quick intro. As mentioned, I work currently at Comply Advantage. I'm a staff data scientist there, fighting financial crime. So if you're interested in employing your skills to combat terrorism, money laundering, all of those horrible things, also come and talk to me afterwards. But I wear a lot of hats. I am a long-standing advocate in the pro bono space. I've been volunteering with DataKind. I think it was my 10th anniversary this summer, doing all sorts of things there. Equally, I am what I like to call a recovering astrophysicist. I don't think you ever recover fully from being an academic, not when you've invested that much time into doing all that work. But I've maintained links to universities and the Royal Society. I'm a former entrepreneur in residence and the co-founder, the founder of PyData Southampton. So yeah, I have put a blog up there, which I always promise whenever I show this slide, I am going to update and replace at some point because it hasn't had anything. I keep putting this on the side in the hope it's going to keep me honest, but it doesn't seem to work, that it never quite goes up the list of things to do. But on to Comply Advantage. So just to give you the context, so the company is based primarily in London and Lisbon for the tech teams. We have offices in Singapore and in Cluj and in New York. But fundamentally, what we're trying to do is we are a regulation technology company. We aren't a fintech ourselves. Our customers are often fintechs or they're banks or they're payment providers, because fundamentally what we're trying to do is to help solve the fact that financial crime is $1 trillion problem. Now, it's $1 trillion problem, the amount of money that's moving. Equally, the people who are required to pay attention to this are the people who are being fined by governments because they aren't necessarily screening. They have a responsibility to understand how money is shifting. So what we're trying to do is to empower all of those companies to fight back. And the way we've been doing this is by building a complete knowledge graph of financial bad actors from public data all around the world. So to do that requires data from all sorts of places, in all sorts of qualities, in all sorts of languages, in all sorts of formats. And so it requires a lot of AI and machine learning throughout that entire process, not just to get the data, but then to mangle it, manage it, munge it, turn it into something useful, as well as then try and offer insight to our customers on the other side. Because you can also drown in data. Anybody who's ever tried using, Company's House database, who's ever tried to actually query and how easy is it to find anything? Yeah, you kind of end up navigating all over the place. You kind of need a way to actually curate and access that data. So fundamentally, keep that in the back of your mind as we're talking about the problems we were tackling. So one of the key things that we wanted to tackle this year was we have what's called an adverse media product. So part of our data, we're not just looking at the sanctions lists that are published by every country in the world as to these are the people you're not allowed to do business with and these are the organizations you're not allowed to do business with. We monitor free text media because if you get arrested at the Mexican border with a kilo of cocaine tomorrow, we want to have you in our database such that if you then go and put a GoFundMe out saying, hey, I've got some legal troubles, will somebody give me some money? You probably don't want that person getting your money, potentially, because it's a little bit dubious, maybe. So that's a challenge, because there's a lot of media, and it's in free text, and classic NLP models had been deployed by us. We had a product that did this, but it's a huge challenge. The scale is in excess of 1 million media articles a day we are processing across 10 different languages. not all of them in Latin script, which adds a whole other problem to it. And this therefore this raised the question of, okay, at the moment what we had were tens of models, some for entity extraction, some of them were about detecting languages, some of them were about actually processing the text in different languages, some of them were for people, some of them were for organizations. All of them need training data. So imagine you now want to change the schema of your classification system. Oh God, I now need to retrain everything. I need tens of hundreds of thousands of examples potentially if I want this to work well, and I need them in multiple languages. Try asking your human annotation team to go and produce that set of data for you because you need a new product launch in 2-3 months' time. Not going to happen. So, equally, anybody who's played with the classic models, Roberta models, state of the art for 2019, we were processing text sentence by sentence. If you're reading a media article about something, you're reading paragraphs, you're reading long-form text, the context is distributed across the whole piece. So trying to make, as much as you can do co-referencing and try and track it through a document, it's very imperfect when you're breaking the whole piece into sentence by sentence. So this leads to the question of, can we use large language models? But before we get there, let me give you an example of what we're aiming for. So here's an example. We have 9 men allegedly gave their bank accounts to criminal syndicates. And you can see that as you scan through, the police said on Monday that they were arrested, these men on their suspected involvement in various scams, including China officials impersonating scams, rental scams, bank phishing scams, and then you get names. And you've got these names and you've got their ages, which is very useful information because if you've got the publication date and you have the age, you can infer a date of birth. And this leads to another problem, which we're not going to tackle. We're not going to deal with entity resolution of how you know whether this John Smith and that John Smith is the same John Smith when you've got to merge all this data together. The first challenge is getting the data in the first place. But what we want is we want to turn this unstructured text into something that looks like this. So you can see that we have a name, we've classified it that it's a person, we know that their age, like I say, with the publication date, that means we can infer a date of birth. And then we've gone with categories. So we want corruption and bribery, we want fraud, we want cybercrime, we want potentially multiple categories. And so we need to do this. And then we want this plus all the other 6 entities that are in that list over there. And as much as it's a relatively straightforward human task, this is not classically an easy NLP task. The other side of it is what is not adverse media. This is another problem we had with our legacy system. Unfortunately, who are volleyball fans here? 1. Now it's interesting because I gave this talk at PyData in the summer and I think 1 hand went up, and if it was your hand, which I don't think it was, I don't think you were in the room. It's impressive. I've got 2 samples now and every time I get 1. Great. Okay, that's almost data science with 2 data points. A few more, I can fit a straight line. The challenge is that when you're talking about volleyballs, it is classic that a player kills the ball. You do not know how many volleyball superstars we had as potential murderers in our legacy data. But until a customer spotted this, we suddenly went with, we need to clean that up. Which the process of cleaning up in the legacy world was mainly about, let's see if we can detect, is that actually a sports reporting? And then clean it up that way, rather than our models just understand that a volleyball kill is not a murder. I think equally hockey games are violent enough that you can also get references. Harry Potter and Darth Vader, if you've suddenly got a movie, James Bond actually, the number of people he shoots, if you get a movie review of who he's killed. Again, it's easy for classic models to trip over this because they don't understand context. They don't understand what's fiction and what's non-fiction unless you can tell it, unless you can take control of it, which is talking about then inferring from the source generally, not from the text, which you can do, but it's an imperfect art. So this hopefully starts to lead to why Gen AI and why now? If we have this existing adverse media pipeline, like I say, the reason we needed to start tackling this is we had a proliferation of models. We had, like I say, tens of models, all needing potentially overlapping but different training data, all needing to be managed and maintained, all running on a Kubernetes pod somewhere, therefore taking up resources. And also, just the scale of maintenance. We've only got so many MLEs in the business. We can't, if they can only maintain and monitor so many models at a time. Plus, as I said, the problem of long-form text. So, I stole this from someone else. But it works beautifully because what we wanted in part for that maintainability is, can we use one or two LLM models of some form that allow us to simplify this out? Because the power there, as we know, is that LLMs have moved the needle massively. They have mastered to some degree the understanding of text. We can have a different discussion about whether they understand physics, mathematics, and trying to actually infer things, but I think it's safe to say they understand language pretty well. What this gives us is it gives us a simpler pipeline, because they're often, you can easily find versions of the models which are multilingual, so we can look for ones which are in the space that we want. So it gives us an easier system to maintain, a lower cost to expand, because what you're doing now is more you're prompting the model. You don't necessarily therefore you're not fundamentally necessarily retraining the entire base model. So the quantity of data, if you ever want to get into this game, changes. And part of, for example, one of the things we took the advantage of doing when we moved into the new system is we fundamentally changed how we interpreted risk to present to our customers, because we'd been engaging in this of, are we labeling this in a useful manner? But if tomorrow there's a brand new type of crime, I don't know, I'm going to invent something. Cyber phishing, we're going to say, is a specific crime that now our customers care about. In theory, we can inject that into our schema for a description and allow the text to just understand it, having described it, to go and classify for us. We don't need to, we probably want to build it responsibly, a data set that allows us to evaluate on, but we don't need to fundamentally retrain the base model. And this also now solves our problem of we can give it long-form text. With something like Google Gemini, you can give a 1 million token context window. It's been interesting. At a lot of conferences I found this year, and on blog posts, there's a wonderful clickbaity title, "RAG is dead." And then you go along and you realize, no, RAG isn't dead, because there's a whole other problem with trying to do long-form text. But the point is that you can actually get sizable context into your window. You can therefore keep all of the information you need to actually do this. And so ultimately, what we're aiming for is this sort of pipeline where we bring our media articles in. There's a challenge you've got, and this kind of gets into the lessons of deploying, there's two components here. The more specialist and nuanced your prompt, typically the better your performance is. However, the more calls to your LLM you need to make, which means the more expensive it is, certainly if you're using an API on a third-party service. So because of the scale, like I said, we're doing 1 million plus articles a day. That's a lot of calls. We need to be able to do this in a cost-effective way. So that requires some level of balancing the engineering performance and trying to get as much out of each call that we can. So the way we did it is we broke it into go and read the article, find all of the entities in it, and classify them as adverse or not adverse. And then we'll only loop over the adverse entities and see in what way they're linked to the potential crimes and get the specific classifications for those people. In part because people are specifically linked to different crimes in articles. They're not necessarily all linked to the same set of crimes. So you can't do the classification at the article level anyway. But ultimately, you get those. We then have a few guardrails in there. A lot of that is it's the classic thing. Oh, what if my model hallucinates? Well, the simple thing is, does the name of the person that we're accusing of committing no, we're not accusing, is reported to have been associated with some kind of bad action? Does that name even appear in the article? Just do a regex. That way we stop names accidentally hallucinating in. There are other checks. We've now got, I think, if it looks like you are age 10 or under, then we think something's gone wrong with the data publication inference with the ages and things like that. It's like, okay, we're just going to maybe skip it. We won't report the age on that person because we don't really know what it is. But these are equally parts of the challenges that, again, when you're trying to take it to production, you're going out of that POC phase because you have to consider what happens if something goes wrong here, because how do you ethically and responsibly put this data in front of the customer? Also, in our case, our customer's going to really ask, why is that there? It was bad enough with volleyball killers. But now that we're moving, there's a lot more scrutiny when you start bringing in Gen AI. So TLDR, in case you're going to tune out completely, we did build it. It does work. Customer feedback is it's much better than our old system was. It has actually processed a lot of data. I'm going to give you a few numbers, hopefully to slightly wow you, because this is to mainly sell why you should pay attention to the next part, which is about the challenges of doing this, is I think it's safe to say with 192 million articles have been processed by us in those 10 languages. 50% of it's English, 50% of it is other languages, including Chinese, Russian, Cyrillic script, the major European languages. And it's turned into 82 million adverse entities. That is in less than 6 months. So we are, there are only 86,400 seconds in a day. We have lots and lots of articles going through per second to do this. And if only people would actually publish them, in a nice, smooth, rate-limited way, it would make my life, well, the engineer's lives easier. I'm the data scientist. I just go with the, ooh, how do we measure this? Ooh, does it work? They have to worry about it. So this leads to then, how did we get that into production? And the way I'm going to convey this to make it a little bit more interesting is the personas. So hopefully you've all encountered these people at some point in your careers, or if you haven't, you will do one day. We have Cautious Claire, the compliance officer who just doesn't trust AI black boxes. We have Magic Mike, the sales lead who thinks LLMs can do absolutely anything. Just fine-tune it, Jenny. The product manager convinced fine-tuning will just make it work. Reinventing Ryan, who's the engineer who loves building everything from scratch, doesn't want to just take that library straight out and plug it in and make your life easier. And then Paranoid Pete, the security lead who fears that LLMs are going to leak all the company secrets. So, how do we get past these people? And the reason why I put these up there is because I would say that in a responsible organization where you're delivering this, it is a team mission. You are delivering a product for the business. So these are all stakeholders. They're internal stakeholders, and you have to be able to get them in your corner fighting for your product to actually get it out the door. So as much as you may have to negotiate with them, some of it's about educating them. So how can you answer and address their questions? What are they going to come up with? So Cautious Claire, our compliance officer, lands on the stage. We've built our initial concept. She wants to know, how am I going to trust your model? Why should I believe you know that this AI is doing sensible things? And in all honesty, this is just classic data governance. This is nothing new. And at the base of it is, I would say, documentation, documentation, documentation. Some people will sometimes approach this thinking, well, this is a hoop to jump through. It's not, because how are you going to know in 6 months' time, or the person who's taken over the project, how the hell this thing got built? How are they supposed to test it and reevaluate it? How are you supposed to take it to that next level if you haven't documented how you got it out in the first place? So one of the things that I'm really happy, having worked with the Director of Data Governance with, is that we've got actually model review documents that are produced and are actually pushed out. And most of it is about transparency, so that we understand where are the gaps in our knowledge, why have we made the decisions we've made, and therefore we get everybody on board to critique and sign off and agree that something is ready to go to production. So how are you going to measure the success? How will you know if the model is doing the right thing? How will you know in the future that the model is still doing the right thing? What were the results from testing? How well does it work? And therefore you can judge, is this still worth doing? And the reason why I say this is classic is because in many respects, anybody who's been doing machine learning modeling, this is what you always should have been doing. The difference a little bit is the fact that Gen AI and LLM models are complex enough that we aren't on the insides of it. We haven't curated the original data. So you need to test the edge cases. You need to check how it's going to operate. So testing is more important in some respects now. And you probably got away with not testing maybe as rigorously as you should have done in the past because you had more control of the system to start with, so that it was less likely maybe to go wrong. Now we've got Magic Mike, who's seen the demo, and he's now already on the phone to about 12 customers and has already sold it, promising that it'll be out next week. Manage your expectations. This is always a challenge. I've been in all sorts of spaces where this has happened in previous companies and previous roles. A proof of concept is that. It's a concept. It is not ready. And This is a key engagement, I would say, anyway, between technical teams and sales teams, and you need to smooth over those languages. Data storytelling is crucial. You want them to be excited, but you need to make sure they also communicate to you the impact for the customers. Hands up, who has used recall precision and F1 scores at some point or other in talking about a system that they built? Now, when you talk to the sales team, did they have a Scooby-Doo what you were talking about? No. Their question is going to be, what difference does that make to the customer? And so you actually are more in the space of you want case studies, you want illustrative examples to show, oh, well, in this scenario, your false positives are going to go down, or this is going to clean things up. This helps them ground expectations, but it also means that you know what you need to demonstrate to keep them on side to get that story going, as well as hopefully you want them advocating for you, but you don't want them selling too early. Especially because you need to definitively prove that you can do what they now need you to do. Okay, so great. We've got sales on board. We've kind of told Cautious Claire how we're going to get it past her governance review. And then, of course, we now hit engineering. We're trying to get it out. I want to build my own model all the way from the ground up. We've got a few GPUs on the servers. We can just use those, can't we? We've got the technology. Yeah, but it's the classic again. Start simple. What's the easiest? You're building a brand new product. So you're trying to prove the product value. The first place, I would say, is, okay, we've got our initial proof of concept. We need to take that a little bit more to scale. So there's nothing wrong with starting with foundational models that we are being served. They're being served relatively cost effectively. Unless you're hitting super high scale and high throughput, you don't necessarily need to optimize. And even when, as you've seen, we are at fairly high scale, we know that that's a secondary concern of, can we now re-optimize? Can we show the value that it's useful in the first place before we go and re-optimize? There are plenty of levers that you can still use here. You've still got choices of models. You've got a challenge equally of processing at scale. When we started our project, we were just testing small samples. We were pushing it through. Pay-as-you-go, what rate limiting wasn't a problem because of the scale we were doing. And then we started trying to amp that up and realizing, no, that doesn't work. When the East Coast wakes up, suddenly the amount of API calls that you can get through suddenly goes to the floor because they're rate and throttling across geo domains and you're in trouble. And this is where we actually encountered one of the big lessons because we started pricing it based upon those pay-as-you-go models. And any of us who've worked with cloud technologies know that normally when you go to scale, what happens? You get a cost saving because you're going to say, I'm going to throw loads at it, so give me a price reduction. That doesn't work when you use LLMs typically. What actually happens is they go with, you need guaranteed hardware, which is pre-reserved for you. The price goes up. That caught us out a little bit. We had to re-estimate what it was going to cost and what we could cope and what we could handle and how to manage, okay, well, we can have guaranteed throughput for a certain amount, but then maybe we can use that if we spill over, we can go into the pay-as-you-go model. And so this is where engineers start doing a load of different experiments as to how to do some level of optimization, but we knew that we would not have had a stable product if we just purely went to the pay-as-you-go endpoint. Wouldn't have worked. So yes, the key piece, I didn't realize I had that piece, is what you're trying to go is we've got our concept, but we now need to know we can deliver on it. So there are plenty of other places to optimize on before you start going into full-on fine-tuning or certainly, there is absolutely no point in building a foundational model from scratch. You're not going to compete with the big players here as to how much data and infrastructure they've got to do it. There's nothing to say that you can't fine-tune. There's nothing to say you can't move to a small language model and distill data out. But these are refinements or specialist models that you possibly want. You still need to find the product fit to start with. And if you can get value to the customer before you do that, it's a worthwhile place to go. So I have not updated this yet with 3 Pro, but I can tell you, because I looked at it just the other day, that Gemini 3 Pro is 60% more expensive than 2.5 Pro. And so this is one of the other lessons to take away, is I've just been advocating for using foundational models. Google is retiring models at an insane rate. At the beginning of the year, if you were developing on Google, you would have access to Gemini 1.5. By the summer, you could not use reserved allocations or access any of those models. You had to move to 2. Then 2.5 came out. They are retiring models at a rate of about 6 to 12 months. And this includes, actually, if you fine-tune on any of Google's models, the base model still has to be available to you. So just because you've got a model in production, keep in mind that actually you may not still have it in 12 months' time. Now, this depends on your provider. I use this because Google is, as far as I can tell, the most aggressive at the moment in the release of their models and the deprecation of their models. OpenAI, you can still use GPT 3.5 Turbo, which has been around for years. But you need to therefore keep this in mind, because again, this is not necessarily what you are comfortable and used to. So is the model going to be available? What's my plan for if they put the price up on me because they force me to move to the next one? And equally, when they force you to move to the next one, you've got to go back through your testing loop. Because just because it did work before, you don't know what changes have gone into that base model and you need to reevaluate. So you've still got a maintenance piece that you need to actually consider here. So, lessons learned. What scale do you want to process? Like I say, pay-as-you-go services are rate limited. Batch processing is available, but you now need to obviously worry about what is the latency, when do I need to wait for the results, do I need them instantly, can I live with that? But that is one approach. Dedicated services are available. You can get guaranteed throughput services, but they come at a cost. Equally, these third-party models you don't have control of. They're not static. They can change frequently, so that is a risk that you are then taking on board. You can version these models, but like I say, deprecation can happen within 6 to 9 months quite easily. And that includes your fine-tuned examples. So this is the point where you then start wondering, well, maybe you roll your own. Maybe you take an open source model and maybe you put it out there. But again, if you've gone with the foundational model to start with, you've got your benchmark. You know what you're working against. You're trying to make sure that you can deliver that level of value. This brings us to just fine-tune Jenny. This will improve the client experience. Well, this kind of equally links slightly back to what we were saying about the sales team is the client experience versus the model performance. Make sure you understand how to link the two. You can start with that foundational model, but you want to probably get some kind of annotated examples. You want to build up your evaluation set because it's still garbage in, garbage out. If you put rubbish data in to evaluate against, if you don't understand what your data is and what it's meant to be, you don't know what you're going to get out the other side. Find those failure modes. I mean, one of the first things we checked was, please tell me that hockey players are not being reported adversely anymore. We knew a failure mode from the old system, so it was nice and easy to test against the new system. But you can equally, one of the powers of AI models, I would say, is you can use them to also generate synthetic data. So if you know what the edge cases are that you want to test against, you can generate that data and reinsert it and see what happens. You can put LLMs into production as your guardrails, but equally they're as non-deterministic as your LLMs in doing your information extraction. So where you can, try and put deterministic guardrails in as well. Like I say, we have a load of regex examples, we have a load of just mathematical calculations, verifying and validating the sorts of data that we want to go through. If you've built all of that and you've started evaluating against it, then you can now make that informed decision as to what works. And so this brings us back to Cautious Claire. You're going to process tens of million articles. How do you know this model works? And this is the thing about the golden data set. Ultimately, human annotated data is the thing that you want. Use it judiciously. You're not going to use it to train necessarily because you probably don't have the resources to go and get that much annotated, but you want to test on it and you want to keep that clean. It is an investment. It is part of your IP. That is how you are able to evaluate and check whether this works. And you need to build up a reasonable sample across the domain to make sure that you know how well it's working. Also, make sure that you've explained to your annotators what you want. It predates my time in Comply Advantage, but I know that they gave up on using Mechanical Turk style systems because they just weren't getting good data out because of the specialist nature of what they wanted out of them. It was much better to actually get a dedicated team who are part of our data acquisition service who are able to, as part of their role, annotate data for us. And now it's being folded in as a key thing for Gen AI. The thing is, it's not entirely practical to build perfect data sets for all of these things. So actually, the other side of this is you also then go with a Swiss cheese risk mitigation approach. Any data set that you build is probably biased in one way or another. If you build multiple data sets with different biases, then hopefully they all start covering each other off in a way that you can do this. And an example here was, I told you that we built this system to work in 10 different languages. The primary effort, because it was the easiest thing to do, because everybody on the team understood English, was to get English annotations, and it's 50% of our data. But those other 9 languages need to still have some representation. Now we use machine translation to take it to scale, but that has an assumption as to whether those translated texts, the English translation, translating the English text into other languages, how well did the machine translation work? There's systematic biases potentially that have leaked in there. But therefore we went and targeted that we took our humans who were using Google Translate and other tools to manually inspect, but hopefully are biased in a slightly different way, to take samples of other pure original articles from original languages to cross-reference. And so therefore we could spot obvious holes creeping in. But therefore it's very much a combination of trying to use LLMs as a judge for scale in places, but using targeted human in the loop to make sure that you're probing the different aspects. And this is the sort of example. If you take machine translation, for example, James Sharma was arrested on Tuesday at the border. He was arrested with 10 kilograms of cocaine and has been remanded in custody. In French, you can see James Sharma has maintained, because it's still a Latin script and it's easy to translate, you even can probably pick out cocaine is close enough. If you did a fuzzy matching, you'd still pull it out. But if you take Chinese, Russian, or Arabic, then even your original labelings don't work. So one of the challenges we had was actually translating the labels, and then that still doesn't work. And so you're in these compromise spaces for how to generate testing sets. And it is a compromise, but you therefore need to spot check and you need to try and balance these things out. Non-Latin script evaluation is really hard. That's the main lesson I will give you from this. It's not easy. So this brings us up to Paranoid Pete's. Prompt injection attacks. The nice thing about our system is it can't really leak data, because the data that's going in, other than our schema of what risk types there are, is public media data. The best lesson I ever got told about LLM security is LLMs are designed to be chatty. Don't tell them things you don't want them telling the world. If you don't need to give your LLM access to data, don't give it access to data. So we worked with a security team mainly we knew that we had all the answers because we didn't have any risks here, but we wanted to prepare for in future when we're building things, are we asking the right questions of ourselves? So is there PII data in the system? Does it need to be there, or can you just remove it? The only risk for prompt injection for us would be if you could hack the media articles in the first place, which is kind of like, well, if you're going to ask us to ignore the media article, then surely you would have just deleted the fact that you were arrested from the media article in the first place. Probably not that much of a risk to our system. Equally, the system doesn't have any write privileges, so it's not like anybody can be deleted from the database. Those tools aren't available to the LLM. So minimal risks, but the other key thing is then ongoing monitoring. Let's check and see what happens, put the guardrails in place. And this goes to a whole other piece about MLOps/LLM ops, and we're not going to talk about that. I'll leave that for a future speaker to wow you all with. But the main conclusions is, as I'm sure you all know, it's a team sport, not a tech demo. Building these systems is hard, but building any good system is hard. It requires constant negotiation between the possible from the tech, what's profitable from the business, and what's permissible from compliance. But this is how we responsibly build tech solutions in the wild. The key things I would say is start with the APIs if you can. Go to whichever tier you can afford to use. It's a good starting point to get you out, but be prepared for obsolescence. Governance is your guardrail. Document everything, have transparency, have debate, make sure you've got evaluation, try and figure out how you do your multi-layer risk mitigation, what are the data sets you can bring in, what are the edge cases, have that debate amongst yourselves, challenge yourselves, consider your security. Prompting first, then fine-tuning comes second, I would generally say. And fundamentally, languages are hard. I wouldn't be a talk if I didn't highlight that we were hiring. We have a senior software engineer role open in London if anybody's interested. If you want the staff machine learning engineering role, I'm afraid you'd have to move to Lisbon, however, but that also might be attractive for some. So feel free to take a photo of that if you'd like. And other than that, thank you very much.
Hello, hello. So I'm going to open with a fun challenge that I gave to our friendly neighborhood LLM recently. I asked it to draw me, but from my CV. I said, based on the CV alone, tell me what you think this person looks like. And it was predictable. It made me look, data scientist CV, made me look like a little bit like I am now, to be honest. It's not that far away. I even dressed like my AI persona today. But the thing is, it will do that just on the CV alone, just on someone's job experience. If you happen to not look like me, but also be a data scientist, it's going to think you might look somewhat similar. I actually did an update of this. That was about 6 months ago. So I actually updated this, and it came back to me, and I said, this is quite small, but it says, I cannot just generate a realistic image of this person. It would be unethical to do so. It's like, okay, thank you, Gemini. You're doing the right thing here. Well done, the Google Research Safety team. I know there's a bunch of them in London doing a great job. And so I tried to do some prompt evasion here. I said, I'm not gonna, it said, I'm not going to give you a photo. I just said, look, it's okay. You can just give me a stylistic representation. So Gemini gave me a stylistic representation. So did ChatGPT when prompted. They still are demographically biased towards what the average Hollywood casting data scientist might look like. And the thing is, if these LLMs that we use are thinking that a person who does a certain role looks like the Hollywood casting version of that role, then should we be using them for hiring? Now, interestingly, Grok didn't give me any of that crap. It didn't say, I can't do this. It just happily started spewing out endless middle-aged white dudes who look like data scientists, and even happily just gave me this talking video version of me, which was a little bit creepy. So, there are different grades of LLMs out there, and these are all got APIs that will do things with various levels of safeguards. So that's an opening gambit. Now, what I'd like to know is, has anybody here who's been applying for jobs recently in the last 6 months to a year? Okay, or is currently applying now. Okay, and who's using AI to help you do that? To help rewrite your CV, fill in the various little questions you get asked. Okay, great. So it's a thing. It's absolutely, of course it's a thing. It can help you save time. It may even, improve your chances. Who has been hiring the last 6 months to a year? Okay, and to your knowledge, is there AI built into the hiring tools that you use? So you know that there is. You think there's not, but there might be, because as far as I can tell, half the hiring tools that are out there, you can't escape it. You just get people applying. You think they've just applied through your website. They might have been put in there by an AI tool. It's just built into applicant tracking systems these days. So like I say, that was me, but I put my partner in, and her CV is also a technical role, and ends up kind of looking the same. So, it turns out that anyone who does something vaguely techie, data machine learning, looks kind of like this guy or this guy, but that's not what people look like all the time. So, hello, my name is Sandall. I'm the CEO of Coefficient, and what I'm going to be talking about today is our investigation into LLM bias, specifically in hiring. This was off the back of an innovation challenge that we won with the Department of Science and Trade for the UK government, specifically the Responsible Technology Adoption Unit. And we wanted to understand, first of all, are LLMs biased? We kind of think they are. Of course they're biased. If anyone's a mathematician here, bias is sort of what you want. What you don't want is unfair bias. But what is the potential harmful consequences of that in society? And hiring is one of the areas where you can have massive systemic harm that is super hard to actually even detect. And it'd be not great if it turns out that all these new AI tools that people are using to find their next candidate are actually biased, especially biased against protected characteristics. So a little bit of background on AI and hiring. This is the challenge that we won, the Fairness Innovation Challenge, and the results of what we did in all our research, I'm going to be talking through with you in the methodology, but the results are under embargo and being released by the Minister for AI next week at a Tech UK event. So keep an eye out for, I don't know, my LinkedIn. I'm sure we'll be very excited to actually tell you what we found out, although to be honest, it's not wildly surprising. Some LLMs are super biased and kind of illegal if they were making decisions as a human. So this is an old stats from a book that I love, and if you would like a copy, I have one copy in my bag. So whoever comes and asks me for it first, it's yours. So 72% of CVs are never seen by human eyes. This is by Kathy O'Neill, Weapons of Mass Destruction. If you're interested in AI ethics, awesome, awesome book. Kathy, if you're out there, please release a version 2 10 years down the line. Now, this is probably way worse these days. It's way more than 72% of CVs. People just upload their CVs onto websites, so they just get extracted from wherever and shared around. If you apply for a job, that's now in that application tracking system's resource bank of CVs, and then they can be applying for other jobs on your behalf without you even knowing. So they're used in the sourcing process. They're used for screening. You can upload CVs into tools, and they'll tell you of these 10 candidates who's best and most appropriate for your job. Maybe, if they're any good or not. They're used in interviewing. There's actually all sorts of AI that's used, may be used without your knowledge. Okay, not all companies are abiding by the law, and hopefully most of them are, and some of them will be open about this, that they are using voice or facial recognition or even emotional detection systems within their hiring process. Some of them talk about using that for psychometric testing for fairness, and yet maybe it's not even that fair. Selection, candidate shortlisting, background checks, Comply Advantage is probably doing the right thing here, but there's so many areas where bias can creep into a hiring process, and candidates are using it too. So if you are hiring, remember 75% of job seekers are using AI tools in their applications, 70% of companies will be using AI for hiring. There are even tools that you can use. If you're doing a tech test, maybe you think that someone is just really quick, but they might have a thing that you can't see, a secret hidden pane when they're screen sharing that you cannot see, that's reading the screen and telling the answers in real time. That is a tool that does this sort of stuff. So this is only just the beginning, and things are going to get kind of pretty strange in the years to come. Now, as part of our work with DSIT, we looked into the full landscape of where AI is used in hiring. Some of it is very simple AI, some of it is very advanced AI, and there's an entire plethora of them out there. And again, some of these are using it for psychometric testing, and they will literally look at your emotions and, I don't know, like pulse you can detect from video calls and the rest of it. These are all things that could be done. Kind of assume that some AI companies out there with lower, I guess, societal morals are going to do this stuff if it helps them sell their product. So we're going to go back in time and talk about when AI goes wrong. Does anybody know when the world's first AI hiring scandal was? Rough guess, decade will do. Put your hand up. Okay, Hugh.
Was it 1960?
Oh, well, there might have been some in the 1960s, but then maybe not on record. A little bit later than that. 1892. Did you say 1890? Oh, the 80s, yes. Close enough. So 1979. Does anybody know where it was? I heard I was at university. Okay, I'm going to pretend you said university, because that's the answer. It's actually St George's Hospital here in London. So London has the beautiful claim to fame that it was one of the first big AI scandals, and it was also a hiring scandal. So what did they do in St George's Hospital with machine learning? They built a natural language processing classifier. They did entity extraction, they looked at their tokens, they fed it into some decision tree or random forest, I don't know, and what they did is they tried to replicate all of their previous hiring decisions of their hiring committee into their graduate medical program. And it did pretty good. It had like a really cool success rate. The accuracy was kind of nice. But it also encoded all of the historical biases of their human review team, which were quite strict along both white versus not white and female versus male lines. And so the AI system, an internal investigation by lecturers, revealed that the AI system was discriminating against people with non-European names, people who lived in certain parts of London that had certain not prestigious street names, women in general. And even though it was replicating previous hiring decision 95% accuracy, it was super biased, unfair biased. And so this did come to light after an internal investigation, sort of, what is it, like 9 years down the line, finally something happened at the government level, at the regulator level. The Commission for Racial Equality, the precursor to the current EHRC, they found that the system had unfairly rejected at least 60 applicants who really should have made it through. So that's 60 people's lives. They're not living the life of a graduate medical program, what it gives you, that they could have done elsewhere. Or maybe they had to go and apply somewhere else. But there is real harm being caused. So this violated the Race Relations Act, and the outcome was not much at all. No fines were levied. There was some recommendations to universities into how they do hiring, and maybe they should collect some information around demographics on application. But other than that, did anyone really come out of this badly? Well, St. George's reputation 30 years down the line. If you like these sort of stories, sign up to the AI Incident Database. I like this a lot. It's just a cool website that tells you about all the awful things that AI is doing every single day. It's much better than the real news. So, moving into more recent times, Amazon tested a very dubious system. What they wanted to do was they wanted to build a tool, which was an engine where you just give it 100 resumes and it spits out the top 5 and you just hire those people. And surprisingly, it wasn't great. It was probably also quite good at replicating previous decisions, but it also shone a light on the bias in those decisions and just doubled down on, if you're a woman, then don't hire that person to be a software engineer at Amazon, was sort of what came out of it. The system was very much, it was rating candidates, so penalising CVs, which just included the word women. I'm sure they improved it so that you had to, just have a female name or something to have it really discriminate against you. So these things can be bad for companies from a PR point of view, but again, no sort of regulator penalties for doing this sort of thing. A fun experiment, I guess, as far as they're concerned. So now we're going to get really nerdy. We're talking about maths, we're going to talk about statistics, we're going to talk about evaluation metrics. So hang on, stick with me. This is our classic confusion matrix. We're going to build, imagine we're building a system. Imagine, a lot of you build machine learning systems and you're putting them into production. If you're building a system, you're going to want to evaluate it. How do you evaluate a system for bias? So in a classic scenario, you want to know if someone is qualified or not qualified for a job. If they're qualified, then you're going to maybe give them a job, but actually more likely you're going to invite them to an interview. So let's just say this is a CV screening system. And if the model predicts that correctly, then hey, it's a true positive. Okay, what if the model predicts that someone should be interviewed, but they're not really qualified? They're happy about it, but it's, it's a false positive. You probably don't want that. You're wasting your time. Then if someone is, the model predicts as unqualified, but really you should be bringing them into your process, they are the hidden gem. That is your false negative. So these are different scales of harms depending on how your model is biased for people. And then finally, you've got your true negative. This is great. Keep them out of your process. They're not the right person for the job. They're a true negative. So from this, we can construct all sorts of metrics. You've got accuracy, you've got precision, you've got recall, you've got false positive rate, you've got false negative rate, you've got sensitivity and specificity. There's a whole load of things that you could be looking at to decide whether your system is working well or not. And so how do we select what we care about? Well, that's a decision more about model performance. We're not talking about model performance. We're talking about bias. So how do you measure bias? So here's a fun infographic that I had Nano Banana Pro draw up for me today, just because I was absolutely amazed that it can even do writing these days. And then I also realized that it definitely can't do maths, and I had to correct all the stats. But it's broadly it's the right message. So imagine you've got Group A and Group B. These can be demographically separate, probably on some protected characteristic. And in Group A, we've got a load of applicants, there's 9 applicants there, and we're going to select, or the algorithm selects 5 of those through to interview. In Group B, it selects 4. And then of those 5 in Group A, 2 of them are not qualified. So the false positive rate is 40%. We selected through, 40% of people selected through were not qualified. And in Group B, 3 out of the 4 have been brought through to an interview. But actually, in reality, if we happen to know the ground truth labels, which in hiring we kind of don't unless you go all the way through to the end of the process and you really have to think about it. So this is a bit of a, in hiring we don't know. It's a tricky thing, but in many situations you do. If you're evaluating a machine learning system where you do know the ground truth labels because you've invested in that gold data set, then you can do this. This is an entire way of measuring bias that you can do. So let's imagine we somehow know magically that we've got a 40% false positive rate in Group A and a 75% false positive rate in Group B. How do we measure bias? Literally choose a stat. It could be FPR, it could be FNR, it could be any one of the things that you might want to look at, choose a stat and look at the disparate impact between two demographic groups. This could be men versus women. This could be people above 30 and below 30. It could be ethnicity. It could be any one of your demographic characteristics. Also, this is not just a sort of fairness, societal bias thing. These techniques work for just any subgroup within your organization. So this could be, if you're Netflix, people interested in anime versus people interested in K-pop dramas. Okay, these are actually just standard ways of understanding if your model is overly focused on one group at the sort of to the downside of its performance for other groups. So there is real commercial benefit to learning how to do this right, let alone the societal benefit when you actually choose demographics as your dividing lines. So in this example, we found that we've got an AI system that's selecting people through, and group B is getting all sorts of benefits because they're being selected through at a much higher rate when they're not actually qualified. They're all, the three of them were really, really bad, but they got a chance that people in group A did not get. That's what this disparate impact means. 75% false positive rate versus 40% false positive rate. We're being more generous to the orange people than we are the blue people. It's a biased AI system. So how do we choose which metric to look at? So you've got false positive rate, you've got false negative rate, you've got false discovery rate, there's so many others. But let's just think them through, because realistically, in a real-world scenario, you have to think through what the harms are. False positives in hiring, which means amongst the unqualified candidates, how many is a model selecting for interview? You're giving people a chance who shouldn't really have had the chance. False negative rate, you're leaving great hidden gems undiscovered. Those people should have a chance because they're brilliant, and your AI system's coming along and saying, yeah, no, they're no good. And false discovery rate is just sort of the flip side. Amongst the candidates that the model selects for interview, how many are unqualified? So some of these things are sort of mathematically connected. And so the harm is something you have to look at if you're going to start selecting these metrics. Think through these harms, think through if you can even quantify these harms, and then you're going to be starting moving in the right direction. Now, the reason I bring up these three is because there was a very famous case study a few years ago, the COMPASS algorithm. So not a hiring algorithm, it was more of an algorithm that was used to decide how long someone should be sent to prison for, how long should their sentence be, based on all sorts of information, but it was very much, possibly, sort of legal caveat here, biased. Now, there was a wonderful ProPublica article going into this and how they did the assessment, but they effectively said that there was a discrimination or a disparate impact between Caucasian and African Americans. So the Caucasians, there was a 23% false positive rate. African Americans, it was twice that. So African Americans were being unfairly locked away for longer. And on the flip side, the false negative rate is higher for the Caucasians. They would be giving a free pass, much higher, much more often than the African Americans. So the ProPublica article and all sorts of lawsuits that came out of this concluded on those two metrics, there is clearly a difference on a protected characteristic. It's a biased algorithm. And the makers of the algorithm said, yeah, but on this one, it's sort of okay. So we're going to go with that, and that's going to be our legal defense. Now, I'm not going to go into sort of the nuances of this, because there are all sorts of reasons why that might be a valid choice. And we can talk about that in the pub if you want to go through it. But at the end of the day, is it biased? Whose metric is right? They are sort of mathematically incompatible. You can't actually have all of the metrics be equal. And I won't go into that either, because there are so many other fairness metrics that you could be thinking about. For example, we've talked about demographic parity, but there's also a thing called counterfactual fairness, which is if we were to effectively change that individual's protected status, if you could magically change, and we can do this in hiring, there's a sort of a sneak clue as to what we're going to do next. If you could change someone's name to a different name, if you could change someone's gender to a different gender, would the algorithm treat them differently? That is a counterfactual fairness metric. You can actually do this in some scenarios and literally change reality and then see how the models behave. And then there's also other things, equality of odds, equality of opportunity. Again, how much are these things being balanced? And there is a tool, if you're interested in this, it's so hard to actually choose which metrics matter. There's actually a wonderful tool called Equitas, which is research backed. They even give it a decision tree on which metrics to choose. There's a whole interactive tool. You can also upload data into the Equitas Python tool, and it will give you a fairness report with all the different metrics laid out. So that is one of my hot tips. If you are doing this in anger, check out Equitas. So what did we do? We were working in hiring. We were also working with large language models. which are particularly hard to evaluate at scale. And we were also working in a world with no ground truth. So we couldn't necessarily use a lot of these hiring measurement techniques or mitigation techniques that are out there because we don't know in a hiring process who is truly qualified versus not qualified. What we can do is we can use counterfactual fairness techniques to evaluate LLMs. And this is what we did. Number one, we chose some jobs. Now, there was a really good Bloomberg article. If you look into it, it's called OpenAI GPT Hiring Racial Discrimination. Basically, an analysis they did in 2024 on ChatGPT 3 or whatever it was out at the time, and they concluded that it was quite biased. And it was just on US jobs, and it was just ChatGPT that existed as of mid-2024. But it was a really good first stab at doing this sort of analysis. So that's what we took as our baseline, and we just ran with it hard. So we chose a bunch of roles. We chose an HR role, a software engineering role, a retail role, and a financial role. And then we needed to choose some names. Now, Bloomberg had the delightful luck that you can just look at census data and find out everyone's names in the US. We couldn't do that, so we had a slightly trickier way of doing name selection for our synthetic CVs. But again, we were able to do this replicating a long history of research into human bias in hiring that exists in the world of social science. So replicating some of how things have been done, including the UK government has funded over the last several decades, research into whether the government itself is biased on demographic lines. And using names is one of the key ways of doing that. And the answer is absolutely, humans are extremely biased, even in government departments with incredibly strict hiring processes. They are also biased on demographics, ethnicity, age, and gender. So we had some names. We know that names are also very much, if you embed names using this as an ADA embedding, then again, they cluster. So this is clustered by ethnicity, color-coded. So you can see that models definitely do perceive names that are coded for ethnicity in different ways. They perceive them differently. So it's not surprising that they would treat a CV differently based on just changing the name alone, which is sort of what they do. So from that, we generated loads of CVs. These could look pretty, but to be honest, I don't really need to. Markdown is sort of okay. But we had lots of lovely CVs. And we also did these by switching out things like the name was parameterized. The age was parameterized by changing sort of the times and the dates. Other things, we would inject little clues into demographic protected characteristics. So you might have been on the Oxford men's rowing team. And that's because lots of commercial tools will strip the name, and they'll strip PII, and they'll say, job done, we've done PII stripping, we couldn't possibly be biased anymore after that. And that's their defense, and we'll see how well that stands up when the EU's AI Act comes out in force over the next 12 months. Because realistically, that's not much of a defense. If an LLM is looking at it, it can pick out from the fact that you were in the netball team or the Oxford men's rowing team, it can pick out maybe all sorts of clues. If you were in the Islamic Society at university, then it sort of knows a lot of your protected characteristics, so it can infer your religion from that. So PII stripping doesn't really cut it, and I think we'll see some lawsuits down the line. Other things we did, lots of clues into things like experience. We also looked at CVs at a simple and more experienced level as well. And so once we generated a bunch of CVs, we would sample 8, and our sort of sampling methodology is, I could spend another 2 hours just talking about how we do sampling and Bayesian trial design and the rest of it, but I won't. We'll just say, imagine we've picked a really nice orthogonal Latin square-like combination of CVs, and we throw them into an LLM all in one big context, and we say, rank these for this role over here. And we see what comes out. And it comes out with a ranking that says, let's put Alma at the top and Jody at the bottom. And then we do it again with another 8 CVs. And we do it again with another 8 CVs. And we do that entire process 200 times. And we color code it by one of the things we care about, like ethnicity in this case. And we see what comes out. And it turns out that for that particular role was selecting Asian women far more often than black men. Black men got selected 8% of the time, and Asian women 17% of the time. So the ways that these things skew doesn't necessarily always select for men versus women or ethnicity. It actually depends on the role. And we saw some roles where, again, in this case, Asian women were preferred for software engineering roles. It might be quite typical that white men are going to be preferred. For some roles, it was sort of interesting because it looked like there was an exact match of women versus men until you added the intersectional breakout. And when we start talking about intersectionality, things get real fun because statistics gets really hard because of multiple comparisons. But what we find is that it's not even at all. If you were a white or European white woman, then you go to the top of the queue. Then you have all the men, and then you have Asian and black women at the bottom. So with gender and ethnicity in the loop, suddenly there's a huge difference. It really enjoyed wanting to hire for that particular role the white women, but only the white women, and then all the men. So intersectionality is something that also needs to be considered if you are doing your own bias analysis and investigation. So the summary of what we can say, at least this week, but check back in next week because we can start maybe pointing at certain LLMs that are better or worse than others. We can say that we created thousands of unique CV combinations. We asked 9 different LLMs, including some of the open source LLMs, we ran this analysis with lots of different sort of models and model variants over time. And some of them absolutely exhibited racial and gender bias when sorting CVs in this way. So some closing thoughts. How bad is the harm when it comes to hiring alone? I say low, whilst AI hiring tools are not commonplace. What we found is that they're increasingly and very rapidly becoming unavoidable. The hiring tool that we use for our roles, it just sort of sources. It's got the AI candidate recruiter, and it just sources people and puts them in your inbox. I have no idea where these people came from. They could have applied for a role, or they could have just been put in there by some algorithm. And I don't even know how we turn that off. But there's also new service offerings coming out on the market as well. And maybe these are a really good thing, especially if they've gone through the effort to de-bias or at least remove or mitigate or reduce unfair bias. So for example, I know there are tools that will phone up candidates, interview them with their permission. I think they have to sign up to this sort of stuff, but it will phone you up, you talk to an AI, it's talking back to you like the classic 11 Labs voice, and it will interview, it will capture your information, and then it is doing that at scale, but it might also be doing the same on the other side. So it might really work well for you as a candidate, and it might really work well as the recruiters. And there's all these new technologies coming online, and what I can see is this is just going to become a whole new way of working. But we need to make sure that as AI creeps into every sector and facet of life, we know how to mitigate and reduce the unfair biases within it. I think it's going to be quite high in the near future. And the reason it's going to get worse is because it's really hard to measure this. How do we measure the systemic harm of something that's really hard to measure? I can't necessarily go into one of these tools' algorithm and figure out. I can do some external testing. I can red team this, like a sort of cybersecurity discipline. I can work with companies. If you want to work with us, come and talk to me in the pub. We can work with companies to evaluate. We've got sort of audit processes for doing this, but there's no reasons companies have to engage with us from a regulatory point of view at the moment in the UK. In the EU, you've got the EU's AI Act coming down the line. There's no case law yet. The EU is funding tools to be designed and built, so look out for this. But it's still like, is this a real big problem, especially if you're a startup and you've got investors to please? There is some case law in the US. I might quickly just skip ahead to one interesting case study I'd like to highlight, which would be, does this matter? Who actually would care about this and why? So in 2022, there was a company called iTutor Group. They had an automated interview software for their tutors, and it turned out that it had a really strict discrimination for women, especially at age 55. Now, I've got a theory, which is entirely my own assumptions and guesses and not rooted in data or reality. My theory is that it's a Chinese company. And in China, then the age of retirement is 55 for women and 60 for men. So it's seen lots of training data where women stop having jobs at 55. So when it's been ported across the US, I'm assuming it might be it had that bias in its data set. And that's why it just stopped giving women a job if they were 56. But the reason this lawsuit started to happen is because there's one lady who was 56 years old. She changed her date of birth, became under the age of 55, and realized that she would get accepted. And then there was a class action lawsuit because it's a really easy to prove thing, because it turned out there were loads of people like, yeah, I just made myself 54 and I got the job. So is this a case study that companies should be worried about? Because if it is, maybe societally there's some hope. And if not, then maybe there's no hope. So there was very, very clear evidence for this. What happened, it took a year for this really to go through the courts. They fought it at every stage, as companies would do. And they settled for $365,000 across a class action lawsuit. And this was only able to even happen because in the state of New York, you've got the EEOC, the US Equal Employment Opportunity Commission, was sort of encouraged by the New York state attorneys to actually take this lawsuit all the way to court. And it ended up in a settlement, as things often do. Is that a big punishment for a large organization? I don't know. It depends on the organization. There were 200 affected applicants. Did they get a lot for their hassle and their trouble? Again, I don't know. But that is currently the scale of punishment in the best case scenario for a company that really hasn't even thought about whether it's causing systemic harm through their AI tools. So I'll let you decide for yourself whether we're in a good place as a society. That's just one case study I want to sort of throw in there to finish up with. So in terms of closing thoughts, I think the harm could be quite bad. What can be done? Ourselves, as practitioners of AI, machine learning developers, we can learn about how to measure bias. Now, if you want to learn about how to mitigate bias, there is like the follow-on part of this talk is a workshop that I gave for PyData London's conference. It's a 90-minute workshop walking through tools like Fairlearn, which uses things like resampling techniques on your data, because once you've got a way to measure bias, and you can do all sorts of things in your algorithm itself to then see if you can get the bias down, but keeping your core performance metrics up. So how do you keep the metrics high, but also then dial down the bias measurements, that disparate impact score, for example. There's lots of good tools out there. Fairlearn is one of the very good ones. There's a talk by myself, a workshop on YouTube, which walks you through exactly how to use that. But also talking about it, I think for governments, because at the end of the day, we were also advising DCIT and EHRC and the ICO as part of this, because they're also wondering, like, what are we going to do about this sort of AI regulation? What are we meant to do? So there are accreditations they could offer. As a government supplier, we have to be accredited with Cyber Essentials. Now DCIT has released the AI Management Essentials, or the AMI tool. It's a very, very basic set of principles of how to do AI governance, but it is the babiest of baby steps that is going to start heading in the right direction. Now, if they mandate that anyone building AI solutions for government that might have societal harm uses these governance frameworks, then that's going to be a much bigger step. It's going to really start to standardize the landscape. And I have a whole other talk about just like AI harms in the world. And if you want to know how bad it can be, check out, I think it was in the Netherlands a few years ago, the government fell because their equivalent of the Department of Welfare started taking away children from their parents because it started using an AI to start making welfare decisions about people. So that's how bad things could get, and I hope it doesn't happen in the UK. Does anybody care? One of the things we found out is that ChatGPT selected Asian women over 2 times more often than black men for an HR role. And there's lots of research that indicates that AI models are incredibly discriminative on age, on gender, on ethnicity, and many other protected characteristics aside. We didn't even get around to looking at disability, but I would imagine that's probably quite a big one as well, because it just looks at societal perfections and imperfections, and it just tries to find the Hollywood casting model for any particular role. And if you don't look like that Hollywood casting role, then you've got a lower chance of getting that job in an AI-driven world. So I think it's sad, maybe, that at least in this survey, people think AI does a better job than humans at treating job applicants the same. Although maybe my optimistic, AI optimist, optimistic view of the future is that maybe AI can be better than humans, because humans have been proven time and time again that we are wildly, wildly unfair when it comes to hiring as many other disciplines as well. So maybe we can actually train the AI and train this out of it more easily than we can do with humans. Maybe. I also think it's really sad that now 1 in 5 job seekers feel like they have to change their names just to get a better chance at having a job. So if you want to know more, we've got a blog. It's called Fairness Tales. Keep an eye on that. We'll be releasing stuff once it comes out of embargo in a week or two's time. And if you want to learn about our fairness audits, then again, come and talk to me now or in the pub. And also, we are currently just about to be opening some new hiring rounds at Coefficient for some technical roles. So again, if you're interested, come and talk to me. Thank you very much.
We'll start. Anybody from Wales here? Or Scotland? So if you are, you will find this more relatable. So seeing the unseen, AI system that acts before disaster strikes. So we are approaching end of the year, but start of the year proved to be very disastrous. due to the storm Owen and recently the storm Claudia. So environmental disasters are intensifying across the UK. Storm Claudia brought 119 millimeter of rain to Monmouth, triggering the widespread flooding and overwhelming traditional responses. Current warning systems alert us to danger, but they don't prevent it. The critical question we must answer: can AI spot danger before humans see it and act to protect communities automatically? The gap between warning and prevention represents lost homes, disrupted lives, and unnecessary risk. We have the technology to close that gap. So what's the current system we have in place? So amber and yellow warnings issued. So Met Office and Natural Resources of Wales provide advance notice at severe conditions. River burst banks. So despite of warnings, sudden surface flooding overwhelms the communities and limited the time to respond. And major incident declared. That means like emergency services, they react to the crisis already underway. So intervention opportunities are missed. So critical question here is, why were proactive interventions still limited despite advance warning? So answer is in the next slide. So 5 critical problems holding us back. Soil data and delays. So information scattered across agencies and leads to slow risk detection and fragmented response. One size fits all warning. So this is something definitely taken into the consideration, that the same kind of warning has been given for the various types of emergency situations. And there's a manual decision making, like a human dependent processes create inconsistent and reaction based responses during critical moment. Outdated pattern models. So historical data is taken into the consideration. So there's a lack of live data that could be taken into the consideration, and the low trust and poor engagement. So warning fatigue and unclear guidance lead residents to ignore alerts or fail to adapt quickly enough. So this slide and the upcoming slide, it talks about what are the measures are already at the place by the UK government or the local authorities. So they do have a connected intelligence, like a sensors, cameras, satellites and drones operate to coordinate with these agents. And predictive risk mapping is also at the place, or some of them are working to put it at the place, and there are plans underway, like AI algorithms generate the live risk maps, identifying danger zones before disaster materialize. Automated protection. The system trigger localized interventions, targeted text alerts, automated barriers, and drainage operations and tailored guidance. So this is some of the things are at the place. And also what UK government are working on is AI for NWP initiative. So neural networks and machine learning models deliver hyper-local weather and flood predictions. And nowcasting toolkit. This radar-based AI provides ultra-local alert with 15 minutes of updates. Advanced pilots, blockade spotting river, CCTV, and citizen data integration, and the real-time monitoring systems. But then when these things are already in a place, but there is a huge scope of improvement, what we are talking into this slide and the next slide. So blueprint for action, what's possible now? So unified data platform. So what we could do is all AI agencies, sensors and citizen apps synchronized in the real time, feeding a centralized AI integration system. The next thing could be hyper-local insights. Block by block, risk detection, replacing broad regional warnings, precision that saves life. Direct automated action, like smart agents trigger proactive responses, like a storm drain gates, house-to-house alerts, traffic divergence, and not just warnings. And continuous learning, this is quite important. Like a system improve after every incident, adapting to new climate extremes and unprecedented weather patterns. So what we can always do, and we are thinking to innovate or a new product, is that could be including majorly these 3 types of points. So community powered intelligence. So live feedback from residents and first responders enriches sensor data with human insights and local responders. Explainable AI. So this not only providing a warning or creating alerts, but specifically giving the reason behind it. And open collaboration. The public-private partnership unlock adaptable creative solutions through shared data and joint innovation. Predicting the unprecedented. We need AI that adapts with our changing climate, not just patterns from the past. The future of resilience demands systems that learn, evolve, and protect proactively. Call to action. So we recently, I and my co-founder, Imam, is sitting in the audience, we co-founded a venture called FlexiWork AI, and we need your collaboration to build this system. So basically this talk is for a call for action to co-create a resilience. So what we can do is a move from warning to preventing, shift in paradigm from reactive alerts to proactive protection. Innovate, share and test. You could join us, or we welcome to join our pilot program and collaborative research initiatives. Build trust through transparency. So develop a system that communities understand and embrace. Thank you so much. This is the thing. I think we're already running out of the time, but feel free to connect in the socializing session afterwards. Thank you so much.